Hi students, problem number 11. In Young's double slit experiment, when violet light of wavelength 4358 angstrom unit is used, 84 fringes are seen in the field of view. But when sodium light of certain wavelength is used, 62 fringes are seen in the field of view. The wavelength of the sodium light has to be determined. Okay, first you must know that the wavelength of violet is different from the wavelength of sodium. Okay, so when sodium light is used, how many fringes are formed? It is given 62 only are formed. But when violet light is used, 84 fringes are being formed on the screen. So let us write two equations. First one is for violet light. Okay, for violet light, the distance, okay, or the number of fringes formed on the screen, delta x is equal to 84. So 84 times beta. What is beta? Beta is called the fringe width. So in terms of wavelength of light, this is also equal to what? 84 into lambda capital D divided by small d. So this is equation 1. Okay students, 84 times beta is equal to 84 into lambda d by small d. But now some subscripts we will use, subscripts for violet light. So here beta 1 for using violet light. Similarly lambda 1 for wavelength of violet light I have used. So beta 1. So 84 times beta 1 is equal to 84 into lambda 1 d divided by small d, because capital D and small d are the same. Only the wavelength of light used is different. So capital D and small d remains constant. Next, for sodium light. For sodium light of a certain wavelength, we don't know the wavelength. So in the field of view, delta x is equal to how many fringes are being formed? You see here 62. So this is 62 times beta, and this is equal to 62 into lambda capital D divided by small d. So this time for sodium light I will use the subscript beta 2, and this is 62 into lambda 2 into d by d, and this is equation 2. So I am going to equate these two, because in the same field of view only number of fringes are different, is it not? So delta x is called the field of view, means that distance in which the number of fringes are visible to us. In the same width, when you use violet light, different number of fringes are formed. In the same width, when you use sodium light, some other number of fringes are being found, but width is the same. So delta x is the same. So I am going to equate the right hand sides. So 62 into lambda 2. So 62 into lambda 2 into d divided by small d is now equal to 84 into lambda 1 into d divided by small d. So the constants d and small d can be cancelled. After cancelling the constants, 62 multiplied by lambda 2 is equal to 84 multiplied by lambda 1. Therefore, lambda 2 must be equal to 84 divided by 62 into the value of lambda 1 is given as 4358 angstrom unit. So this is 4358. So this is equal to, now 84 divided by 2. So if I divide by 2 means this will become 4 2s are 8 and 2 2s are 4. So divided by 31, 42 by 31 into 4358. So we will multiply the numerator 42 into 4358. So this is equal to 183,036. So this is equal to 183,036. 36 divided by 31. So this is divided by now 31. So this is equal to 59. This is equal to 5904 angstrom unit. So finally we got the answer for lambda sodium. The wavelength of sodium light is taken as lambda 2. So the answer is 5904 angstrom unit. So you can see here option B is the correct answer. Understand that? So option B is the correct answer. So this type of numerical problems many times they have repeatedly asked in the previous competitive exams like AIEEE, JEE, mains and all. Okay. So here what is the concept you are using in the same field of view, the number of fringes will be different for different wavelengths. Understand? So delta X will be the same irrespective of the wavelength of light used. So when the wavelength of light changes, accordingly what is going to change is the fringe width. Beta 1 and beta 2 only will change. Okay, I hope you must have understood well. Fine.